look at that, they're like, it's unfactorable. But it can be factorized, just you have to go into the realm of complex numbers, which not everybody enjoys. Understandably, I mean, complex numbers are called the complex numbers for a reason. Friggin' complicated sometimes. Anyway, so moving on. 3b, and we have s over s squared plus 4s plus 4. Now the bottom can easily be factored to s plus 2 squared. And so now what we're going to do is we're going to factor it into a over, actually it works, a plus 2, so a over s plus 2, sorry, plus b over s plus 2, no, this is not going to work, damn it. Oh, maybe. Yes, well, yes, haha, because of the s. So what we're going to do is we're going to take a and multiply it by s plus 2, and then we have b. Sorry, this should be squared. So we have a times s plus 2 plus b is equal to s. So we have s times a is equal to s, so a is equal to 1. I really like having a equal to 1 for some reason. Not in that problem, but generally. And then we have 2a plus b is equal to 0. And we know that a is equal to 1, so we know that b is equal to negative 2. So, this leaves us following fractions of 1 over s plus 2 minus 2 over s plus 2 squared. Now we'll do the Laplace transform. And one thing to keep in mind, if you have, say, if you have the same addition to all s's, then what you can do is you can actually have, you can actually factor in an e to the negative whatever straight away. So in this case, it would be e to the negative 2t outside. And what you do is you convert all of those s plus 2's straight to s's. So then you get 1 over s minus 2 over s squared. And so this just equates to e to the t times 1 minus 2t, I believe. Does that seem right? From here to here? Just double check.
Okay, wait. So we did, the first one is, so if you do the Laplace transform on 1 over s, it's 1, yeah?
Yeah.
And then 2t, yeah.
Okay.
According to me anyways, Caitlin.
Sorry. And there we go. That is our solution for B. And just let me know when you're done with A.
You know what, I can probably write these out mostly on my own, like that one looks pretty simple, I'll probably figure it out on my own.
Okay.
I just want to write this down there.
Here?
Okay, so you took out 3i, you factorized 3i.
Yeah.
And then, so you said that 3i a minus b has to be equal to 1?
Yeah.
Why?
Because from here, we saw that a plus b is equal to 0.
Yeah.
So then both of these terms went to 0, meaning that this was the only term left to equate to I.
Why did that second term go to 0?
This one here,
Yeah. Why didn't that one get equal to 1?
a plus b, a plus b. A plus b is 0, so because we had 3 terms here, right?
A has to be equal to minus b. Okay. I don't see how you can just like assume that. Like I know you're right, it's just I'm trying to think like.
I know normally it's the 1 that is equal to the 1. This time they
Yeah.
threw a bit of a curveball. Yeah, essentially what it is as long as you have a constant coefficient, which technically this is a constant coefficient, right? I is as much of a constant as pi or er, or square root of 2 or whatever. But yeah, normally it's about 85 to 90% of the time this will be the term that you're looking at. But every 15...
Is it because s can't be equal to 0? Like,
yeah.
Like the term is equal to 0, but s can't be equal to 0, so therefore a plus b has to be equal to 0.
Yeah, like we're essentially trying to solve for
Okay.
the coefficients on everything.
That's right. Okay, that's how.
Because it's another way to look at it is 0s, right? So.
Yeah. Okay, that makes sense. Let me just write that out real quick.
Okay. Yeah, because then whatever the coefficient on 1 would be would also be the coefficient on s. Since we didn't have an s before, right?
Yeah.
It's pretty much factor solve.
If I ever have real trouble with that, I can go back and see. But...
Alrighty. So.
Systems of differential equations.
Spooky stuff.
Okay, I think I remember. Yeah, so if you need two equations to solve two unknowns, and they give you two initial conditions.
Yeah.
So it's good. Yeah. So let me just write these down.
Is it okay if I erase what's on the board right now? You know what they need to come up with? An Etch-a-Sketch blackboard. So you just like press a button, it vibrates and clears itself. How much money would be made off of that for universities? And you know, instead of like, especially in the universities where they have like 8 blackboards, instead of like somebody just sitting there erasing all that, you just like press a button, done.
That person would be the happiest person in the world.
Oh yeah. Mind you, you'd be getting rid of someone's job. Like, you know, if someone were paid to clear blackboards all day, it'd be the shittiest job in the world.
Janitors.
Probably get asthma after like a month.
Okay, so this is solvable.
Which one?
And how?
Oh,
Once you jog my memory, I should get.
For 4? Or okay. So for 4a, this is systems of differential equations, which is even more fun than we've already had regarding Laplace transforms. So we have x prime of t plus y of t is equal to sine of t. Thank you. And then we have x of t minus y prime of t is equal to 0. Where we have x of 0 is equal to 1, and y of 0 is equal to 0. So what we're going to do is we're going to we're going to take the Laplace transform of both the equations, and then we're just going to solve for one in terms of the other, and then put it in, solve it, and then transfer it back to solve the other equation, and then it'll be good.